Pete Yost here for the Unbuild It podcast with a word about our sponsor, Huber Engineered Woods. There are really three reasons why I think Huber Engineered Woods stands out, and it's a big part of why they're a sponsor of our Unbuild It podcast. First, they develop systems of products. The products are compatible and integrated. Makes our jobs a lot more easy in the field and when specifying. Second is superior tech support. There are really good website resources that they have developed for the application of their products, but they also have an outstanding 800 numbered tech team that really knows their stuff. And the last is a really active technical research and development team with whom I've done a lot of work over the years, and I have a lot of faith in the information I get from them when I have questions about product performance. So that's it. That's our high performance sponsor. Now on to the podcast.
Welcome everybody to the Unbuild It podcast. I'm Pete Yost, your host for this week, and I got my good buddy Steve Basic here.
Hello.
And we're really lucky to have a special guest, in part because this is part of our very short but important series from Building Science Summer Corporation's Summer Symposium, also known as Summer Camp. And that is Kohta Ueno.
How you doing, everybody?
Do you know Kohta, Steve, by the way?
Yes. Worked with Kohta for a number of years.
Yeah, so both Steve and I were lucky to work with Kohta at Building Science Corporation. And he's just an amazing building scientist. And what we thought we would do is we have a bunch of questions from our listeners that are pretty much related exclusively to the building enclosure. And who better to work with us on that than Kohta Ueno? How's that sound?
Sounds great.
Okay. So I'm going to go through the questions and either paraphrase or read the question, and then we'll let you launch in and we'll see how we go. And we have a whole bunch of questions. Sometimes we do one or two, and sometimes we get through a bunch, but we'll just see how it goes. Okay. So I'm not even sure how to pronounce its name, but I'm going to say that it's Gagan Lamba. And his question for the Unbuild It podcast. We moved into our current home last year. It's a custom-built home from 1992 in Wisconsin. The builder used rigid foam instead of plywood for the air barrier. We are getting bids to replace current wood siding with hardy plank as we have woodpecker damage on the wood siding. My question is if you would recommend adding plywood on top of the rigid foam as we replace the siding. Current plan is to just add Tyvek on the foam and then add hardy plank on top of that. So what do we think about the idea that the original rigid foam was the air barrier, and now we're going to add the rigid insulation, and what should we do with each of those layers?
For sure. So one thing to first think about is let's break down the functions that we're thinking of here. They tell me that the foam is an air barrier, and I'm assuming that the original intent of this wall is that it's a water control layer. I'm assuming this is a classic lower cost Habitat for Humanity wall, stud frame, no structural sheathing, rigid foam, probably tape joints, at least I certainly hope so, and that surface would function as both air control and water control. This is a perfectly reasonable and workable wall. Of course, once you've perforated with the last generation of siding, you have to add a new water control layer and possibly air control layer, just given that you've punched a bunch of holes in it and it no longer functions as that. So the question boiling down to, do you need plywood on that? That I'm assuming that the house has not fallen down yet, given that he's writing about it. So there's nothing that's actually blown it over. There's basically the structural loads have been controlled by other means. So there's no need to add it structurally. Possibly it's worth arguing that it'll make your house a little bit stiffer, but it's not required by any means. Then let's get back to the air control, water control side of things. Putting a layer of Tyvek on the outside that handles the water control beautifully, so you're all set there. Air control, I've never frankly seen a mechanically fastened house wrap as a great air barrier. It's better than nothing. there are all sorts of other options that are way more cost and way more annoying to do. But the last piece of it is, do you actually need it? I'm guessing that the contractor often pushes having a rigid sheathing just to have something easier to attach to. But if you look at the install manuals for Hardie, it says, quote, direct attachment, which is the name of nailing the stuff through foam. That's perfectly by the books. Up to 1 inch is my recollection.
Yeah. That's really interesting, because when I first looked at this question, I was thinking, well, wait a minute. You not only have the issue of how well each of these materials will satisfy as a control layer, but how am I going to attach this new cladding, which is a pretty dense, heavy cladding, weight per square foot? Do we really need, or let me put it this way. If we added the plywood as sort of a nail base for the cladding, I'm not sure the code's going to accept simply attaching that cladding to the plywood as adequate to support that cladding.
Yeah, this is the edge of what I recall. I'm trying to remember whether Hardie's manuals say specifically stud nailing only, or if there's any flexibility. But one thing I've always argued about folks who say stud nailing only, that means you can't apply your product to SIPS construction then, correct? It's a structural insulated panel.
Right. Interesting. Steve, you have any insights on this? For attachment?
I have many insights on this.
Oh, I thought so.
So, totally agree with Kohta. I guess the options that I would provide if that was a client of mine, I would say, listen, you can do a number of things with the foam. First of all, you could tape the joints with a very aggressive tape, or retape them if they are taped with like a Siga Ventrum or something that's highly aggressive. Second, you could put a house wrap over it, but I don't think I would put Tyvek. I would do like a Siga MyVest or their SA product, which is their self-adhering. Clean up obviously you'd want to wipe down the foam, make sure it's not dirty or got junk all over it. Or you could go to like a Benjamin Obdyke SA, which is a self-adhesive. But if it were my house and I was doing it, I would probably put the Siga MyVest over it, and then I would do 1x4 treated battens on the studs and attach my Hardie plank to that.
What's interesting here too is that if the rigid foam was used as an air barrier, and that was 1992, it's hard to get really aggressive tape on the surface of something like rigid foam. Of course, depending upon what type of foam, EPS, XPS, or foil-faced. But seems like a really good idea to do a blower door test on this house, to find out, well, how good of an air barrier do you have before you go deciding, the details of your wall assembly.
For sure. Although, doing a blower door test and trying to look for leaks, it's going to be a bit difficult given, trying to identify every single hole through the foam, that type of thing.
I think it's doing a blower door test to just understand at what level of integrity your esteemed air barrier is working at.
Cool. All right. That's a pretty good wrap, I hope, Gagan, for your wall assembly. And, there's no rule about coming back and asking a second question about the advice that we give. All right, number 2. This is a question from Bill Hulsiek. Lives in a 2-level house. The lower level is being a walkout. The plan currently is to use metal siding on the house, mounted vertically, and run that over Zip R12 sheathing panels and the ICF walls. The siding profile has a 3-inch air gap in it in the profile. Does this approach require a rain screen, furred out with 1-inch plywood strips? My thought is that any water that gets behind the siding should drain down the gap, and there is enough ventilation to drain. Okay, so there's a whole bunch of questions actually wrapped up in this one, but let's go through it using our continuous control layers.
I just want to give the quick answer. There's the famous line that, you ask an engineer the time and he tells you how to build a watch. So if you wanted the quick answer, it's just that, yep, it is a rain screen intrinsically on its own. It has an air gap behind it. It's part of the construction. No need to add strapping, full stop.
What's interesting here too is that we really don't know as much about the sort of the what each of the control layers is in this assembly, although we do know they're putting zip R12 on, so presumably they're going to tape those seams and make that the weather-resistant barrier as well as the air control layer. I know he put in here, see attached PDF, and I don't have the attached PDF to know just how that air gap is, but we do know that at 3/8 of an inch, we're going to both get really good drainage as well as some air movement. So if that is the case, I think we're in good shape.
Absolutely. You guys have probably said this on the podcast a bunch of times, but the levels of the air gap are, 1/16 of an inch to provide drainage, making sure we're not damming up water. The usual analogy I give of how big does the gap need to be? You need to be looser than however you stuff barrel staves together so that water doesn't leak out. Or water does leak out is what we want.
Oh, that's interesting.
And 3/8 of an inch, that's a entirely reasonable conservative size for a drained and ventilated cavity, providing that airflow. Could you go smaller? Possibly. Could you go bigger? Yeah, probably. Although going much bigger than 3/4 inch, who cares? And you're increasing fire risks at that point.
Now, I always thought, Kohta, that 3/8 of an inch, 10 millimeter, I always say like that's a good for both drainage and convective air movement. That's a good number, but it's right out of the Canadian building code for maritime construction that we need a 10 millimeter gap between the WRB and any cladding. Is that where you thought it came from, or?
No, I think that the number probably Well, my understanding is that the Vancouver condo crisis promoted a whole lot of this. Basically, 1990s construction, very subpar, a lot of bad flashing details, and massive numbers of failed construction projects, lawsuits, and part of that was pushing into the building code, getting a 3/8 inch ventilated airspace behind the cladding. But my understanding is that dimension predated that code requirement.
Steve, I remember you telling me that you have seen, I think there were even some photos with it, that if you've got that air gap open at the bottom, but it's not open at the top, that you've actually seen, moist air that gets stacked up in there, creating paint peeling off the first one or two clapboards that run in that system. So it does. Kohta, do you agree that makes a big difference, having open top and bottom rather than just open bottom?
Yeah, it's absolutely true that the terms that John Straub uses is a ventilated cavity means openings low and high. A vented cavity means openings just low. So having through flow dries things out better and faster than openings only low. And there's lots of studies demonstrating that.
Now, you do some crazy stuff by putting air gaps all over the place with open joint claddings.
Yeah, we have a current project that's open joint, like 3/16 inch open joint between like 1x4-ish boards. It's multi-width boards, everything from 1x3 through 1x8. But that vertical joint is continuous open joint through the whole wall.
Did you say 3/16 is the gap?
Yeah, it's
Wow.
it's a 3/16 strong. The husband wanted 3/16 because he liked the tighter. The wife wanted the 1/4 inch, so we said just cut 3/16 a little stronger. And they're both happy.
Pretty good compromise. Okay. Question number 3 related to building enclosure details. This is from Michael Ballou, and he says, hello, Peter. So apparently he doesn't really know Steve or Jake. I seek your guidance. Roofs are designed to not leak. I noticed no drive to begin rain screen technology for roofing practices. If sidewalls were seen as vertical roof surfaces, hint of Joe Steebrick there, and treated as such, then we would negate the need to accommodate the water infiltration within and upon this plane. Just for example, consider the standard flashing package that comes with a Velux skylight, which may be some of the best in the industry. Kind of interesting. So do we apply these techniques to windows and doors? Should we be providing basically ventilated rain screens for roofs?
Yeah, so there are some designs of roofs that are essentially a drained and ventilated cavity. We use this all the time when we're dealing with Rich Dude's house out in Aspen, where the snow probably piles up taller than I am, taller than maybe even Steve on some years.
That's above the first story, by the way.
And basically having your, say, a spray foam or rigid foam roof assembly, then strapping maybe 2x running up the slope, creating a open cavity, another layer of sheathing, another layer of water control, and you're cladding on top of that. The reason it's used specifically for ice dams is that by flowing cold air through that, it keeps the snow from melting, avoiding that ice dam problem. But in addition to that, I can also try to sell it as an incredible durability upgrade, because I can tell the client, look, you got 2 roofs on your house. Your first roof starts leaking. Hopefully it gets caught in that lower layer, starts draining out, and somebody says, hey, why is our icicles pouring out of these weird openings in my roof? And somebody hopefully at that point fixes it. One bit of caution, though, is the classic rain screen drained and ventilated cavity relies on things like lapped joints, flat through wall flashings. The whole concept, if you think about it, water runs down through that rain screen cavity, hits a through wall flashing, drains out, and it's out of the cavity, out of the wall. Turn this into a roof, what happens? You're flowing just on the outside of the shingles, and the next hole it hits, it'll come right darn in. So you're not getting a huge, a lot of the rain screen flashing concepts are not necessarily going to apply in the same way. There's actually a pretty spectacular failure of a metal skinned building with a gap behind where water, basically they try to design it like a wall instead of a roof. And guess what? It acts like a roof because it's a wall that's sloped back towards the sky.
Oh, wow. I think what's a little bit confusing about the difference between roofs and walls is that we do provide a vent chute space underneath, which is for, convective drying, but that's not a free draining space for water. So, we don't go inside walls and create that ventilated space. We put the space for convective air movement and drainage on the outside. So it's a little tricky with roofs, I think, because you're dealing with both the top side drainage of water as opposed to running that convective layer underneath the roof sheathing. I get this question a lot. What's the difference between having that vent chute space underneath the roof sheathing or on top? Well, the question is, they both are going to move air through them and get you convective drying, but one happens to provide a great drainage space for water and the other doesn't.
Yeah. And there are cases I've seen of people trying to make a vent chute into something that drains somewhat. For instance, just rigid foam cut to the size of the rafter cavity, lapping the joints, but it's ship in a bottle territory there.
Interesting.
Well, and if on that one, I have some other comments about other stuff, but that one in particular, if you put rigid foam up there, like I've seen guys cut polyiso and put it up there. So now you have an impermeable layer. So you think you're having a vented roof that is connected to a vented airspace, but the vented airspace, you've cut off all moisture migration. So your vented roof is really only venting the underside of the plywood, not the vented roof itself. But as far as rain screen systems, we've done quite a few of them. We just did a metal roof where there's a product called entangled mesh, where we've put that on before we put the metal roof on so that it has a drainage space there if you get any condensation or that building up on the underside of the metal roof. But Cedar Breather's been around for sure 25 years or so, and we put that under wood shingles and different systems there. So there are systems there, but I think the biggest difference is most roofs up until probably recently, and I say recently like 10, 20 years, were always vented. And so the vented roof, there was no cause or concern to put a vented space topside of the plywood because you're getting rid of all the moisture below the sheathing. And so as we do hot roofs and more of them, then it's going to become more of a critical thought in the assembly. But up until now, I don't think that it has for that reason.
And it's interesting. The code requires for shakes and shingles, wood shingles, that you have that space, right? And it's because if you think about it, is that a drainage space or is that a drying space? Well, clearly, when we're talking about wood shakes and shingles, the code thinks that it's for drying. But frankly, any water that gets past that, if there's roofing paper below there, it's actually a drying space and a drainage space.
Absolutely. And also, you can use the same kind of drainage mat under metal roofs. A lot of roofers push back on that, but one specific case is zinc roofing actually requires that because you can get something called hot water corrosion, where basically the zinc pinholes to nothing.
Oh, no kidding.
Yeah.
Because the water heats up so much underneath the zinc roof?
Basically, you have flat smashed against flat, holding onto the water, heats up in the sun. Exactly.
That is awesome.
I saw that on $1 million roof.
Yikes.
$1 million zinc roof that had to get torn off
Like
after a few years.
$1 million hot plate sort of on top of the roof?
$1 million worth of dumpster. All the way roof.
Okay, rolling right along here. We got some really good ones, but this one is from Sean. And it's kind of long, but I have to read this because what he says at the very beginning is, in earlier episodes, Joe Stiebrick's name came up a lot, and Steve always mentioned him in the past tense. It wasn't until watching a video on the Build Show where Matt was on a Zoom call with Joe that I realized the guy wasn't actually dead. Might want to clarify that with your listeners in case they made the same assumption.
Hey, can I clarify?
Yes.
So, Sean, the reason I wasn't referencing Joe's living status. I was referencing Peter and my association with Building Science Corporation.
Exactly. That's just too precious to skip, though. And he says, anyways, I've been looking at a different way to do unvented roof assemblies with exterior insulation, preferably mineral wool, and I'm wondering what the best detail is. The plan is to have 3.5 pitch finished with standing seam metal. I've seen builders install insulation on top of the roof sheathing and the WRB, then attach a second layer of sheathing over the insulation, such as zip panels, then installing ferning strips on top of the standing seam. But I've also been seen builders install the ferning strips directly over the mineral wool, eliminating the second layer of roof sheathing. My question is doing the latter method a bad idea? It's essentially just taking a rain screen detail that works very well on an exterior wall and placing it on the roof. Thoughts?
Yeah. So this is one big step back kind of comment is anytime you're changing to an unvented roof with rigid foam on the exterior, rigid insulation on the exterior, rather than spray foam from the underside, you've just pretty much bought a more complicated roof. Mm-hmm. Basically you have to have the roof structure first. So rafters, sheathing required for structural, then your layers of insulation, and then, we got to attach all sorts of cladding and stuff to the outside. So you're buying definitely another layer as a nail base, something to hold up your cladding, at least in most cases. I've definitely seen that detail where you're, skipping a middle layer, an outer layer of sheathing and just putting various types of strapping, ladder strapping to support a metal roof. That's within plausible. At least I've seen it done with rigid foam and basically taping that layer of foam to keep water out of the insulation sandwich. I'm a little bit hesitant to do that with mineral fiber just because it is porous and open, and also any water that gets in, there's no, what I was saying before about vertical wall cavities, you can flash stuff out and it gets out of the cavity. You don't have any option to do that in a roof. Just think about the slopes and where everything goes. It's stuck in there until it ends out, manages to wiggle its way out at the bottom of the roof.
Yeah, I agree. I mean, my comment to that was you can't say the roof is just like a wall because it isn't. Gravity is nowhere near in your favor on a sloped roof, especially a 3 and 12,
right,
as it is on a vertically, oriented wall system.
So another thing that's interesting about this assembly is that if you're putting the rigid insulation right on top of the structural deck, and then you're putting another layer with furring strips on top of that, you are ventilating the nail base on top of this whole assembly, but you're not venting the structural sheathing back down next to the rafters. So interesting. What could become important is, well, what's your cavity insulation there? Because now you might need to have some drying to the interior, given that you don't have any, drying to the exterior. And by the way, I didn't mention this is climate zone 7A, so we're pretty cold climate.
Yeah, one additional piece, I'm not sure if this is part of the layup that he talked about, but on that first layer of structural sheathing, I would definitely want to have air barrier, keep interior air from getting into your insulation sandwich. And number two, you probably need it anyway, just because you need to put a temp roof on before it's not like this foam's going to be going on the next day, right?
Yeah, interesting point. Okay, so the next question I'm going to go to is from Miles, and he says, "Hey y'all. Thanks for the excellent informative podcast."
Howdy, Miles.
We just bought a 19-level farmhouse smack dab in the middle of Arkansas. Okay, so this is hot, humid climate. It features a pyramidal roof design with a dormer on front and another one at the rear of the house. Not quite sure how it's vented now at the peak, but it has vented soffits. What is the best strategy in my hot, humid climate to insulate and moisture manage this roof design? And I think he's looking for general guidance here on the type of insulation to use in the cavity. I think he's looking for guidance on whether it should be an unvented or a vented assembly. He says also the very high-pitched roof gave the previous owner the idea to convert the middle portion into a sheetrocked conditioned living space. So that's important because we're not talking about a vented attic, or he's now converted this to a living space in the attic space. It has wood slat ceilings at 12 feet high for the first floor and a steel roof, separate HVAC units up and downstairs, and faced fiberglass bats currently in the ceiling joist gaps. Okay, so clearly we're moving from what was probably a vented attic space with the insulation down at the ceiling line, but we have this conditioned space kind of cobbled into the attic. So
It's probably like a cape, right? Where you have the triangular vented open attic. Then you have a cavity or cathedralized ceiling for 4 or 5 feet. And then you have the remaining top third as a vented attic again.
I think you're right. Yep.
Before we get to that, let's clarify one thing. Arkansas, hot. He called it a hot, humid climate.
He did.
So I don't think it's quite hot, humid.
So that's climate zone
3A.
3A. So that's mixed humid, not hot humid.
Yeah, hot humid I would start to characterize once you get down to the red stuff, climate zone 2.
Remember that squiggly white line code in the code? Do you remember that you and I went county by county looking for airport data to find out the number of hours, and where the dew point was above 68 or something? And that was just this crazy ass exercise that we carried all the way from the Atlantic coast over to Texas. Do you remember that?
Really? Was that specific? I would have guessed that it was something like Joe telling us the places where he's done really bad humidity investigations and say, like, these are my dots. You guys figure out a line. Go.
Yeah, that's that was one of the projects you and I worked on together that was just it was only awesome because I got to work with you. Everything else about it was really, really horrible. Okay, so maybe we should answer this question about sort of best practice for what we now know is insulating at the rafter, not the ceiling, for both mixed humid and hot humid. Kohta.
Yeah, so the first question is, can you make this into a vented roof assembly with insulation at the roof line? And my quick takeaway is, with a hip-style pyramid-shaped roof, it's going to be really flipping hard. I know that you can physically place vents on, hip ridges, the hips, but I've heard all sorts of folks push back. So going from there, probably unvented is the most realistic option. Open cell foam, closed cell foam. My slight preference is closed cell, just to avoid humidity buildup product problems we've seen with open cell. But a lot of local installers are open cell guys, and that's what they do. So As long as you add a dehumidifier, I would live with that. Third option is in the code now, there are options for using fibrous insulation, such as dense pack fiberglass, cellulose, in the rafter cavity. If you put a diffusion vent up towards the top of the roof, basically letting any moisture that collects filter its way out of the very top portions of the cavities.
Just sorry to interrupt, but if it's a pyramid style roof that's coming up to just a triangle, then the same thing with venting and the vapor diffusion port, we don't have a whole lot of linear footage to install a vapor diffusion port up there.
That's really interesting because we don't know how long, if any, of a ridge we have if it's a true pyramidal roof. Kohta, what is the deal? How, if you have like a hip that comes to a central, very short or non-existent ridge, how much ridge do you need in this type of configuration of a roof that you can, use the vapor diffusion port across the top of the roof?
Yeah, you can start out to spread out the amount of vapor diffusion port you have by basically drilling holes through the sheathing at the hips and basically coming down a little bit more, catching a few more of those rafter cavities before they're all closed off. Do I have a hard and fast answer? No, not really. Do at least 1/600? Probably more than that, though. There are numbers in the code, but my thought on diffusion vents are make them as big as you possibly can that still fit.
Yeah, and we should mention that I believe it's in the code R806.5 for unvented roof assemblies, and if you look at the number of sort of notes that you have to follow for climate zones 1, 2, and 3, there's an awful lot to consider there in terms of roof pitch and circulating air in the attic space below that so that you don't get humidity stacked up. There's a lot of requirements for this.
Absolutely. And also, it's complicated enough that Joe was hired to write a guidebook to make doing these types of roofs more understandable in human readable form as opposed to code language.
It sounds like this would be a perfect candidate for a vented cupola.
A vented cupola. Now, just want to take note, that's the architect who is, we're sitting here with the details and you go ahead and change the design. That's awesome, right? We'll tell Miles that we hope that cupolas fit into the style of this particular
you can
roof. Create
a style. You can create a nice ultra-modern cupola. You can create a very historic.
Yeah, you could. Yeah, that's excellent. So I just want to be clear, though. We're saying that in both hot humid and mixed humid, that we can use either open cell foam or closed cell foam. Do we have he's asking for sort of best practice. Do we have a preference? I think you said slight preference for closed cell.
Correct. Closed cell is my preference. We've had a bunch of reports, not just BSC, but Green Building Advisor has summarized this too. Open cell foam attics have been reporting a bunch of humidity problems where think of the sheathing as a moisture magnet. With open cell foam, you can basically ping pong moisture in and out of the roof sheathing. It basically accumulates over time, and they're reporting stuff like 70-80% humidity up in that attic. Throw a dehumidifier or some conditioned air, you can make it work, but that's the problem I prefer to avoid to begin with.
Interesting. Now, if we move slightly west of Arkansas and we're in Texas, I know there's a lot of open cell foam being used in those sort of cathedralized attics because of the high hat roof design that's so common. And again, I think they're using open cell foam because it's less expensive per R value than closed cell.
Yeah, when you get south of climate zone 4, all the insulators try and talk you out of closed cell foam very quickly. They're all open cell people.
What about, we do have medium density foams, don't we? Is that like maybe a thing to consider?
Yeah, 1 pound per cubic foot is what I would classify as that kind of middle density layer rather than open cell, 0.5 pound versus closed cell, typically 2 pound. The thing is, I've heard it exists. I don't think I've ever seen it out in the wild. Have you guys?
I have not.
I've I've seen it in literature, but I too have never seen an actual medium density spray foam.
And as much as we like to talk about it, I don't think builders or the insulation industry, the worker bees, mind you, like have a sense of 1 pound, 2 pound foam, etc.
Interesting. I will say that, with any type of spray foam, it's the only product that we're manufacturing on the job site. So part of best practice would be really sure that you pick an installation contractor who has some sort of third-party certification or something to identify sort of, pardon me for saying this, Jake, he's not on this recording, to separate the wheat from the chaff.
Hey, boy, do I have news for you.
Uh-oh.
Because on a recent job, I climbed up in a truck with the insulator, and he explained the whole machinery to me. Do you know that his machinery, if the nozzle experiences any drift in the mix, machine shuts down?
Yeah. Yeah. The really top-notch rigs are incredibly sophisticated. It is like they're manufacturing in an industrial setting. Yeah. But those rigs, they're like $150,000 truck rigs that we're talking about. So that really does separate out it was a great project in Brattleboro where there was a $150,000 chemistry lab in a truck here, and over here there was a guy in a van with 2 barrels of part A and part B, and we thought, well, we know which guys are going to be coming
old
back.
Wooden barrel with a little churning stick, right? It's like, don't worry, Jimmy, you'll be ready to spray in a couple of minutes.
Okay, so I think that might be all that we have time for today, but Kohta, I want to ask you one final question, given that we're here at Building Science.
What do you got, Peter?
Summer camp. We saw a presentation this morning on the new BuildingScienceAdvisor. And I just thought that was an amazing thing that Oak Ridge National Lab is working on. I just wanted to get your real quick cut on, I think it's absolutely critical for our industry, but I wanted to get your cut.
Yeah, I've seen previous iterations of it. I've heard it pitched very well as a building science learning tool rather than a practitioner tool. As I tweak the dials, what kind of things do I find? I kind of have doubts how often it might be used by practitioners, but hey, maybe that's possible. I had a few issues with minor bugs where it's telling me walls that I know work great are high risk, but I'm hoping that those are fixed by now. I've not played with a new version.
Yeah, I didn't know anything about it until here, and the plea from the guys who have been working on this is use it, make it a better tool. I'm pretty excited because in builder trainings that I'm doing, and particularly for brand new people, man, what a great tool this would be to have them, come to the first educational session, give them the website, have them go home and use it, and then we can talk about the next time they come about, well, how did the Building and Science Advisor work for you? So I'm pretty excited about it, as you said, as an educational tool. Okay, Steve, I'm waiting to see if you have a little gem to wrap us up on.
I don't.
No,
I'm serious. This is summer camp week. We got to be serious.
Oh, I was really hoping for one of those closing out with. There's a little tear trickling down my cheek. I'm so sad.
And as far as I can tell, Steve's not hungover, so that's just reality.
Well, Kohta, can't thank you enough for coming to the Unbuilt It podcast. Steve, what do people do to help support our Unbuilt It podcast?
What do you mean? Send money.
I'm waiting.
Send money. It's BACZEK when you're writing out the check. Is that what you're talking about?
I'm talking about smashing the subscribe button.
Oh, yes. When you're on YouTube, you want to smash that subscribe button. But more importantly, you want to send in these questions because we've experienced a real positive move when people are sending in these questions because, it's that whole adage of, 100 people sitting in the seminar, somebody asked the question, but there's 20 other people that were thinking the same question.
Exactly.
And so these questions that we reviewed today and will, the future ones, these are questions that literally there's hundreds of people out there that have the same question.
And those who have been following Unbuilt Podcast for a time, we're getting more and more questions, and that's leading to more and more great Unbuilt podcasts for us to address those questions. And so thanks a lot for listeners for sending those in. Kohta, it is always a pleasure to be working with you.
Fantastic hanging with you guys.
No, thank you, Kohta. We know you're real busy, and it's truly a privilege. For those of you that don't know Kohta, go to buildingsciencecorporation.com. It's easily one of the best resources out there for this level of knowledge. If you ever see Kohta's name on a speaker list, do what you can to get inside those doors, because it's totally worth it.
And just to be fair, the three of us fought for who was going to be dropped out of this. So poor Jake, he got the shortest straw. Okay, we'll see you next time.